Hello, welcome to another section of our soilless farming system. So over the past, I think the past 4, 5, 6, 7 lectures in today's series, we'll be looking at aquaponic system, and we've tried discussing different aspects of aquaponic system. We've talked about understanding what the system means. We also talked about the aquaculture part, and if you want to know more about that, I say you can contact Kinzo Farms or Akin Fish. They'll be able to give you whatever details you would need. Then we also talked briefly about, we've talked about hydroponics generally. So we'll be discussing now the components overview. What are the components you need for your aquaponic system? So we'll be looking at the components. We'll be looking at the components. What are the things we'll be looking at? First, we will discuss the plumbing. So we are going to look at the plumbing. How do you do your connection? How do you ensure the water flows? Where do you use gravity? Where do you need pumping machine? Then we would also look at the grow bed. So for those that want to fix, that want to do something about, that you want to do NFT kind of system, or is it what is the word, NFT type of system, or the raft system, or the flood drain, whichever one you want to do. What is the kind of grow bed? The grow bed is where your plants will grow, essentially, where the plants will be. So we want to know what are the things you should put in place. Then we'll also look at the grow bed stand, where the bed would be. We'll look at the grow bed stand. Depending on the kind of system you are using, we may also look at the float switches. How do you switch from one form to another? Then we have the water pump, what kind of pumping machine. Then obviously we'll also look at water quality. For some of these, take for instance, water quality. I may not spend too much time discussing this because this refers to your pH, your EC, your TDS, dissolved oxygen and all. We have discussed this extensively in the past. We've discussed this extensively in the past. Then we look at lighting. We look at lighting. What kind of lighting are you going to put? The lighting process, what kind of lighting? Then we look at heating and cooling. We'll look at heating and cooling. So we'll discuss briefly the heating and cooling. So we'll discuss that briefly. Then we look at dehumidifier, then energy consumption. However, starting from bottom up, heating and cooling, remember when we were discussing, we said fishes have a temperature they love to stay in. And we said if you must grow a plant on aquaponic system, ensure that the plant and the fish have similar requirements when it comes to temperature. So if, for example, then also remember that we talked about the difference between climate and weather. So if you decide you want to rear fishes that prefer warm weather, you want to rear fishes that prefer warm weather, for example, and the weather they probably prefer is between 22 and 27 degrees centigrade. Now, there might be times where everywhere is so cold that this temperature drops. So in that case, what you are going to need is a heating apparatus to heat up your fish pond. I'll give an example. I think February, March this year in Nigeria, there was a particular period of about 2 or 3 days where the temperature went very high. So for most people, instead of the temperature to reach 22 to 27 degrees in their fish pond, they were recording as much as 40 degrees to 50 degrees inside their fish pond. And lots of fish farmers lost lots and lots of their juveniles, lots and lots. There is actually a story I heard, I think that was a few days back, where someone lost well over 1 million juveniles. Well over. Yes, the juveniles are cheap, 20 naira, but when you lost 1 million of that, that's about 20 million naira gone. And you realize that happened because the person did not have a cooling unit. So when you are building your fish pond, it is important, especially if you are going commercial, understand what is the temperature of where I am going. Do I need to have a cooling system in place just in case? Just in case. Take for instance, we are somewhere in this farm where I am right now, is somewhere in Ogun State, and because of the fact that we're saying just in case something happens, we have a deep freezer here. We have a deep freezer here, which we have put in place just in case there is a temperature surge. So should the temperature go up and it is so high, we have a deep freezer that we always have our nutrients inside that we can use to reduce the temperature, So understand what I'm saying? And I'm not saying have it and make it what is it called? It doesn't have to be an expensive thing. It could be something as simple as a freezer, a deep freezer, and you have your water. If you have your fish pond, your water inside, and the day the temperature is so high, get your block pellet, throw inside to reduce the temperature. Then when it comes to lighting, I think we've discussed this before now extensively. I'll try and see before the end of this series if I can show you an example of a an LED light, but I know we've discussed about this extensively in the past. So remember we said you need to understand that your fishes do not need so much light, they like a bit of shade. However, your plant requires light for photosynthesis, and it's important to know the spectrum of light that the plant actually requires so that you are giving the plant what they need. You are giving the plant what they need. Then water quality, like I said earlier, we have discussed this extensively. You need to know the pH. The pH would affect the fishes. The pH would also affect the plant because the pH affects how easy it is for the plant to access the nutrients within the solution. And then you have your EC, electrical conductivity, and the total dissolved solid. You need to know how much nutrient is really available in my solution that is going to the plant. Then we talked about dissolved oxygen. This is also extremely important. You need to understand how much oxygen is readily available for the plant and for the fishes. So these are things we've talked about. So we'll start from the plumbing. So let's jump to the plumbing. So universally, we use more of PVC for our plumbing. I know you all know that. We use more of PVC for our plumbing. And the reason for this is simple, which is PVCs are universally available. They are universally available, which means anywhere you go to, you have PVC. Almost everywhere you go to, you have PVC. Two, they are considerably cheap. I'm not saying they are like free, but they are considerably cheap. Then we have standard size, which means if I say I need a 2-inch PVC pipe, 2-inch PVC pipe is always 2-inch PVC pipe. So it means you can actually say, it is easier for me to give you a list of what to buy if it relates to PVC. And I know if I say buy 4-inch, 4-inch is the same thing in whether you are in Lagos or in Johannesburg or you are in Albany in the New York City and all of that. I don't know if you get what I'm trying to say. So it's easy. It's much more relatable. Then we have wide range of adaptations and connections available. So it is easy for you to connect A to B, B to C, and all of that. They are easy to use. They are easy for you to adapt, and then they last long, and they don't weigh so much. So it's also easy for transportation. So just a schematic diagram. Let's say this is my fish pond. This is my fish pond. If I want to do NFT, this is my, let's do it. Let's do a complete NFT. Pardon the diagram not being so fun. Okay. So let's assume this is what we have. So So for the sake of clarity, here you are going to have your pumping machine that pumps the water to the topmost layer, and the water comes like that and returns back. So this is just an example, a schematic diagram, an example. So here you have your fish ponds. Here you have your NFT system where you have your plants standing. So the nutrient only needs to go to the topmost layer, and the water flows down like that through gravity and back to the tank. And you realize that all of these we are using are PVC pipes. So here we have the PVC pipes in use. So that you can see. So here we have the PVC pipe in use. Here we have the connectors. So there you have the connectors connecting the PVC pipes and all of that together. Then when you come down, here we have the pumping machine. So there you have the pumping machine. Then here it could be a pulley tube or a smaller PVC with smaller dimension. So essentially you can see the components that we use generally. Now it's important for us to know how to name these things. It's important for us to know how to name these things. So let's do a little bit of naming, because like I said, I want it to be that at the end of these classes you are able to start something honestly. You're able to pick up something and say, okay, this is what I want to do. Now when you look at your PVC pipes generally come in different sizes. So you hear something like 1 inch, 2 inches, 3 inches, 4 inches, 6 inches, 8 inches, and so on and so forth. So what do these things mean? You know your PVC pipe is an hollow structure like that. It's an hollow structure like that. Now, when you look at the size or the diameter of this space, when you look at the diameter of this space, the internal space, the diameter, that is what we measure to say this is whether 1 inch, 2 inch, 4 inches, or 6 or 8 inches. So when they say get 4 inches PVC pipe, we mean a PVC pipe that the inches here or the diameter here is 4 inches. I hope that makes sense. So when we say get something of maybe PVC pipe or this or that, we are talking about this space here. I hope that makes sense. Then another thing again you would hear us talk about is, you will hear the plumber talk about the schedule of the PVC pipe. So if they ask you, oh, what schedule do you want? So what that means is, when you look at your PVC pipe, you know this circumference has a specific thickness. So we could have 2 4 inches pipe. We could have 2 4 inches pipe such that, let me have to try and see if wait just a minute. I want to make it a bit realistic, okay? So let's say these are 2 sets of pipes. So when you measure the internal diameter of this can be 4 inches, and the internal diameter of this also can be 4 inches. Does that make sense? Now, when both of them are 4 inches, you now look at the thickness. This thickness here. Now you realize that this is very thick and this is thin. So the level of thickness or thinness of your PVC pipe is what they call the schedule. Now, generally, there are 2 main schedules. There is the 40 and 80 schedule. So the 40 schedule is the thin one. The 80 schedule is the thick one. Now, in most countries, in most countries where they try to follow standardization, your thin schedule comes as white PVC and your 80 schedule comes as gray or other colors of PVC in most countries. In Nigeria, I don't know, very few people tend to follow the rules of using color to denote what it is. But just remember, the most important thing is one is thin, one is thick. For the purpose of aquaponics, hydroponics, you can actually use your thin schedule. It works perfectly. So please take note of that. It works perfectly. So this is on naming the long PVCs. Then depending on where you are buying, they come in different specific sizes, like lengths, different specific lengths. So they're usually maybe about 1.7 or so meters long, but they sell them in feet. So depending on where you are buying, they will tell you what the feet are. Now that is for the PVC, the length itself. Then we have the connectors. So we have the connectors. So one of the first connectors we will talk about are the T's. So when we say a T, just like letter T. So it's a connector that looks like a letter T. So you have it like that. You have them like that. And like that. Everything the same size. So this is a T. So what do we use T's for? So take for instance, with our, let me put the skeletal structure of a fish pond. Let's assume we want to do flood and drain. So I have my platform here. I have my platform here. And I have my bed. And I have my bed. So I have a pumping machine in here. I have my pumping machine, to be sure it's clear. So the pipe comes out from the pumping machine like that. So at this point where the pipe comes out, I need exactly, I think somebody has gotten it, I need a T to separate this into two. So your T is used for separating a channel or joining two channels. So I can now separate and take water to wherever I want the water to go to. So we call these ones T's, connecting T's. I hope that makes sense. So that's a connecting T. Then we have another type referred to as a reducing T. Reducing. So what is the difference between a connecting T and a reducing T? So you have, again, like a T structure, and this comes and probably goes thin like that. So what you use this for, let's assume where the water is coming from, it can be either ways. It can be like that, or it can be like this. It can be either of the two. They are both reducing T. So let's assume that this pipe that was bringing the water from the fish pond is a 4-inch pipe or a 2-inch pipe. But because I want to reduce and increase the pressure, because by the time I separate the T, the pressure coming from here is being reduced. We want to reduce the pressure so it doesn't come and splash, pa, 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 or something. So I can decide to reduce this to 1-inch pipe. So to connect my 1-inch pipe to a 2-inch pipe, what I need is a reducer generally. So a reducing T is to change from one level of bigness or largeness or diameter to another diameter essentially. So I hope we understand that. Then we have what you call 90 elbows, the 90 degrees elbow. So we have what we call the 90-degree elbows. I'm saying all of this so you understand. So an elbow, just like my hand, you can see this is an elbow, right? So a connector that essentially looks like an elbow, that essentially looks like a 90 degrees. So if you look at this point, here we are going to need an elbow. Here you are going to need an elbow. I don't know if that makes sense. So you need an elbow to take it from here to come down, from here to come down. So your elbow is just a 90 degrees that changes. Then of course you know there is also going to be a reducing elbow, 90-degree elbow. So if where you are coming from is big, you can take it to small. So you can go from 4 inch to 2 inches and vice versa. You can also go from 2 inches to 4 inches or whatever inches. Then we have what we call crosses. So we've talked about the T's. So what are the crosses? Just like a cross. So you have them coming like that. So you have it like that. So there are times you probably want to take water from multiple channel or something, and maybe you want water to come from here, from here, from here, and go here, or water coming from here, you want to distribute here, here, and here. So depending on the need. I am not saying you need all of these to function. I am just saying you need to know their names. So when you are looking at mapping out your aquaponic system, you need to start remembering, okay, for every ton, what kind of elbow or what kind of connector do I need to change or connect my tons? That makes sense. Then, yeah, of course, once we have these, you also have the reducing crosses. So the reducers can be any of them, or 2, 3, or depending on what you want to reduce. Then we have the U trap. We have the U trap. So we have the U trap. The U trap, just like letter U. So they look like that. They look something like that. So when you say a U trap, you use U trap depending on, maybe at times you want to catch some debris. So you want the water to go like this so that it's only the supernatant that gets to flow out easily. Then every time you have to release your U trap to clean them up. So as an example, I will just show a few things. So what I've been trying to explain. So you can see this is the 90-degree elbow. You can see how it bends. So this is a 90-degree elbow that is able to bend. You notice that? So that's a 90-degree elbow. You see we are using it a lot. Is another 90-degree elbow that bends. Then if you look at this place, you can see the T in use. We want water to go this way. Water is coming from here. So there is a T where the water can go out. So let me see if there is. So like I said, they come in different sizes. You can see the elbow again in use here. So you can see the elbow. Then if you look at this place, you can see there is a reducer. There is a reducer going from 4 inch to 2 inch. So this was a big pipe coming, but it has been reduced to a smaller pipe. So you understand that these are things that plumbers use generally and regularly. They use them generally and regularly. Okay, so we've talked about the U trap. I think I'm going to see if we can see the board fully. Then we also have what you call the ball valves, which you use to ensure water doesn't flow out and all of that. Then we have other things again that the plumber use is the Ys, W-Y-E-S. We also have what you call the Ys. The Y just looks something like that. So how do I draw this? So you have something like that, something like that, something like that, something like that. So we'll call them the Ys. So it's either you have water coming from 3 channels and you want to channel them one way, or water from 1 channel you want to channel them 3 ways. Again, like I've said severally, you also have the reducing version depending on what you want to do. Then there is also the 45-degree elbow. So here we have a 90 degree. So a 45-degree elbow will be something like that. Again, depending on what you need to connect. Excuse me, depending on what you need to connect. So I hope that makes sense. Then earlier we've talked about the schedule. So we said the schedule talks about the thickness one. Other things that the schedule also determines is the water pressure. How much pressure PSI can you generate inside um, the PVC. I said there is color coding normally, and there are various applications and usages. So depending on what you need to do. Then other things that we also use as irrigation are pulley tubes. So when we say pulley tubes, an example of a pulley tube, I don't know if you can see this. Let me carry it to where the light is brighter. Let me take the smaller one. So this is an example of a pulley tube. It's not like PVC. You see, it's not that strong. I can press it with my hand physically. I can press it with my hand physically. So this is a pulley tube. So what do we use the pulley tubes for? So let me write them, pulley tubes. Now these pulley tubes come in different form. There are those that look like hose. So this is like a hose. There are those that are slim and small. So we call those ones those ones that you have the slim ones, and you have the ones we call the vinyl tubing. The vinyl tubing, I'm looking around if I would see any. I don't think I have any of them at the moment around me. But we have the vinyl tubing. Just a minute, let me see if I'll get any of them. I'm sorry, I can't find any. I wanted to show you an example so you have an idea of what the vinyl tubing looks like. But essentially, they are way smaller. They are small. Most of them come in form of black color. They are small and really tiny. If you probably go back to some of our past videos, they look more like what we use in connecting air stones. You remember our air stones? They are tiny like that. So you use them to bring water slowly, not under pressure, very slowly. You use them to bring water very slowly. So you notice that all of these things we have talked about so far is how you get the water from the fish or the aquaculture to the plants. So the vinyl tubing are really, really tiny. So which means instead of from here, for example, you can have the vinyl tubing bringing the water down very slowly to flood that. Then next we have what you call let's go to the other part, which is the fish tank. So we've talked about the PVC pipe to the plant. Okay, let me also take time to explain briefly how do you connect the tubes to the PVC and everything together. So if this is your PVC pipe, this is your PVC pipe. Let me see, I think I should see PVC outside. So this is a PVC pipe. I hope we can see it. So this is a PVC pipe. So what we'll do is, so this is like what you have here. So this is a PVC pipe. Sorry, I had to go out to pick this out of the bin so I can use it to explain. So the PVC pipe, what you do essentially is, you know from our hydroponics talk how many holes, the spacing you want to create where the plants will be. So we've created a hole. Now, create the smallest place where the water would come in. Now, the essence of that vinyl pulley tubing is you don't want the water to come in with full force. You want it to be coming in like steady flow of water. Doesn't that make sense? It's not water coming like pressure, like tap when you open it goes. No, you want it to be flowing gently, coming in gently. So that pulley tubing will allow you attain that easily. So the water flows in gently, drops, and it flows through. So from here, the water goes in. So here you are going to be having your mesh nets, your net cups, or whatever it is you want to use to hold the water and the plant while the water flows. Remember, we said you want to ensure that this is a bit slanted, slightly slanted, slightly. So if you are going to have multiple layers, then you are going to put a connector here. So here you will have 90 degrees, join another 90 degrees to the next PVC pipe, like that, till they get to the final level where the water returns to your tank. By tank we mean your fish pond. Now for your tank, remember we said the things that are important is you need to know the size of what you want to work with. We talked about understanding shapes, understand your water flow rate. You don't just want the water to be stagnant all through. You want to know a little bit of flow rate. Then remember to create in and outs, where water comes in and where water goes out. There might be a time you decide you want to clean your pond, so have your in and out. Then, I think that's basically it. So in the next class, I don't want this to be too long. We will then look at